This is exercise 5 of week 2, so let's start with A, or what appears to be A in my order. So solve the following equations or inequality. So if I multiply here both sides by the term 3x minus 3, why am I doing this? Because then I get, multiply this by 3x minus 3 divided by 3x minus 3 equal to 3x minus 3. Now the nice thing is that I can cancel down this common factor here, so I basically get 2x plus 1 is equal to, now I have to expand this, this bracket here, so 5 times 3x is 15x minus 15. And what I can do next is to do on both sides minus 2x, and then I get here 2x plus 1 minus 2x is then 15x minus 2x minus 15. And as you can see here, plus something minus something is just 0, so I get here 1 is equal to, and 15x minus 2x is just 13 times x minus 15, and then I add plus 15 on both sides, so I get 16 is equal to 13x. Then I divide the whole thing by 13, and then I get x is equal to 16 divided by 13. So the next exercise is this inequality here. We can't really solve an inequality, but we can find all the solutions, all the values of x that satisfy here this inequality. So the first step would be that we distinguish two cases. So this is the absolute value, so two things can happen. So the first case would be that 2x minus 1 divided by 3 is positive, which means that 2x minus 1 is larger than 0, because we can just multiply here both sides by 3, and then I have here 2x is larger than 1, and then x would be larger than 1/2. So what I'm saying here is basically that this term here is positive if x is larger than 1/2. So in this case we can leave the absolute values and just write it down as 2x minus 1 divided by 3, so only in this case is larger than 1. Okay, and then I can solve this inequality, so I'm multiplying here by 3 on both sides, so then 2x minus 1 is larger than 1 times 3, which is equal to 3, and then I have here 2x is larger than 4, and then x is larger than 4 divided by 2 is 2. And then we have to check which inequality is actually stricter. So as we can see here, if x is larger than 2, then automatically x is also larger than 1/2. So this one would be stricter here. So our first solution would be that that this inequality is satisfied for x larger than 2. So now I come to the second case, when 2x divided by 3 is smaller than 0, then obviously we have that 2x minus 1 is smaller than 0, and then we have 2x smaller than 1 and x smaller than 1/2. Okay, so in this case, if this is negative here, and we have to take the absolute value of something negative, this means that we have to put a minus in front of it to make it positive. So for example, if I have a negative value, let's say minus 3, and I put the absolute value, it's plus 3. And another way to achieve this is just to multiply this something negative with minus 1. This would also give me 1. Okay, so this is larger than 1. And we can now divide by 3. So then I get here minus, be very careful, put brackets here. It's larger than 3. And then I can divide by minus 1. Be careful, if you divide by something negative, the inequality sign here turns around. So I get here 2x minus 1 is smaller than 3 minus 1 is minus 3. Then I add here plus 1, and then I get 2x is smaller than minus 2. And then I divide here by 2, and then I get x is smaller than minus 1. Let's quickly check. So we have two inequalities here. X is smaller than minus 1, and x is smaller than 1/2. Which one is stricter? Well, obviously, if x is smaller than minus 1, then automatically it's also smaller than 1/2. So this one is stricter here. So our result is that this inequality holds for x is smaller than minus 1. And remember from the case that what inside the absolute value is positive, we had also the result x is larger than 2. So in summary, we say this inequality is fulfilled for all x values that are either smaller than minus 1 or larger than 2. And I'm turning to C. So what we have here is x minus 1 to the power of 2 is minus 1. Well, we can immediately stop here because something to the power of 2 can never be negative. So our answer is that there is no x that satisfies this, because everything what we put inside here would be positive and can never be equal to minus 1. So our answer is here, we're done. No solution. And the last one, let's solve this equality. So what we have here is 4 times logarithm of something is equal to 0. So our first step could be to divide here both sides by 4. And if I have 4 times something and then I divide it by 4, then this 4 just drops. So what I have left here is just a logarithm of something is equal to 0. And then we have to think about when is the logarithm of something equal to 0. Well, you might remember that everything to the power of 0 is equal to 1, and this is actually what we're asking when the logarithm. So every logarithm, the natural or the decimal logarithm, every logarithm of 1 is actually equal to 0. So we must conclude that what's inside the argument of the logarithm is equal to 1. And then what I could do next is just a plus 2, and then I have here 3x plus 1 divided by 2x plus 1 is equal to 3, and then I multiply here both sides by 2x plus 1 to get rid of this denominator, and then I have here 3x plus 1 is equal to 3 times 2x plus 1, never forget the brackets. And then I get here 3x plus 1 is equal to 6x plus 3. And I can subtract, for example, minus 3. Then I have here 1 is equal to 3x plus 3. And then I have here the minus 1. Then I have the, let's take here the minus 3. And then I get here minus 2 is equal to 3x, which is equivalent to x being equal to minus 2/3.